If you've ever coded in Python, you've definitely come across a list comprehension. They're always held up as the really Pythonic way to write code. But it turns out their real power isn't just about saving a few keystrokes. Nope, it's something way deeper, and honestly, kind of brilliant. So let's start with a really basic question that every single one of us has to answer when we're coding. You've got some data, and you need to build a new list from it. What's your go-to? What's the first tool you reach for? Well, for most of us, myself included, the first thing that comes to mind is the good old for loop. It's the trusty workhorse of Python, right? It's dependable, it's clear, and you know it's going to get the job done. Every single time. I mean, look at this classic example. We want a list of the first 10 square numbers. So what do? We create an empty list, squares, then we loop from 1 to 10. Inside the loop, we calculate the square, and then we just append it to our list. It's simple, it's totally clear, and it's really easy for anyone to follow along. But then you stumble upon this other way of doing things, the comprehension. And when you first see it, it just looks like a fancy, more compact way to do the exact same thing. Just a little syntactic shortcut. Just look at them side by side. The for loop on the left, that's 3 lines of code. The list comprehension on the right, it does the exact same job in just 1. It's more declarative. It's like you're just describing what you want. Give me a list of x squared for each x, instead of giving step-by-step instructions on how to build it. It's definitely way more concise. And this kind of gets to the heart of it, doesn't it? As one Redditor put it so well, on the surface, they're basically identical. You take a bunch of stuff, you do something to each piece of stuff, and you get a new list back. Simple. So, is that it? Is that the whole story? Is the reason Python folks get so excited about comprehensions just about making their code a little tidier? Or is there something else? Something deeper going on here? And this is where we get to the real mind-blowing insight, which comes from the blog Iterative Tangents. The real power of a comprehension isn't what it can do, it's what it can't do. Its limitations. Well, they're actually its greatest strength. This quote just nails it. That constraint isn't a problem to be solved, it's a feature. It actually pushes you, the developer, to think in a much cleaner, more focused way. Okay, so why is that constraint such a big deal? Well, think about it. With a regular for loop, it's so easy to just start adding more stuff. You toss in an if statement here, maybe a counter over there, and pretty soon your simple little loop is trying to do 5 different things at once. And that's where code gets messy and hard to debug. But a comprehension, it actively resists that. Its type syntax basically forces you to have one clear goal, which leads to cleaner code with a clear separation of concerns. And here's the really cool part. This powerful idea, this constrained declarative syntax, it's not just for lists. Python uses the same beautiful principle for other data structures too. Check this out. You can use almost the exact same syntax to build sets, which is great because they handle uniqueness for you automatically, or you can build dictionaries, perfect for creating key-value pairs right on the fly. You literally just change the brackets. It's this incredibly consistent and powerful pattern that runs through the whole language. And it gets better. Comprehensions aren't just for transforming data, they can filter it at the same time. All you have to do is tack on an if clause at the end, like in this dictionary comprehension here. So in one single, super readable line, you're creating a new collection that only includes items that meet your condition. It's doing the job of both a map and a filter, all at once. So elegant. Now, an idea this good doesn't just pop up out of thin air. Comprehensions actually have a really rich history that's rooted in the world of functional programming. So before comprehensions became the norm in Python, you'd often see people using functions like map and filter. Map lets you apply a function to every single item, and filter lets you pull out only the items that pass a certain test. And while those are super powerful tools, trying to combine them can sometimes get a little messy to read. A good comprehension is often just clearer. The idea itself goes way back to the 1980s in functional languages like Miranda. Then in the 90s, it really got popular in the language Haskell. In fact, that's where the computer scientist Phil Wadler actually came up with the name list comprehension.
And then finally, in the year 2000, Python adopted this amazing idea, bringing it to millions and millions of programmers around the world.
Okay, so let's bring this all home. What's the hidden power we were talking about? It's not just about writing less code. It's about writing more disciplined code. That clever constraint in the syntax, it forces you to separate your logic. And that leads to code that's more declarative, way more readable, and in the long run, just so much easier to maintain. And that leaves us with one final thought to chew on. This whole idea that a clever limitation can actually guide you to a better, stronger solution, that's a huge design principle that goes way, way beyond just building lists in Python. So the question is, where else in your work could a simple constraint lead you to a real breakthrough?